So now we're going to do some exercises regarding the stack and subroutine. Okay, the first question here. Okay, you are required to answer the following question with assembly program below. You are given a assembly program as here, all right? And then you are going to state the content of the following table after this assembly program is executed right after the instruction RET. Alright, in which the uppermost memory location is 085F. It's already stated that your RAM N, right? So it says that your RAM N, your uppermost of memory location is 085F. So how are you going to what we call to answer this kind of question? All right, so you need to fill up this table here. So this is the table that you need to fill out. Okay, let's ignore the red color ones. Okay, because this is the answers. All right, so you're going to find what is your R26, R27, R28, your program counter, stack pointer, and then your content started from address 85F until 85B. So this is your stacks, right? So first thing first, what you're going to do is first we need to find what is the value for each of these lines here. All right, you need to find out what are the content of each register or the value of your memory for each of this line after this instruction is executed. All right, so first, it's saying that your uppermost memory location is 085F, so you know that your RAM is 085F. Okay, so this is my program memory. Oh, sorry, this is my data memory, in which I can divide my data memory, all right, to three bahagian or three segment. Okay, the first one here, okay, we call it as a GPR followed by IO, and this is your RAM, and your RAM is at 085F, so it is your RAM. Right? Okay, so now, so if you see this program here, this assembly program here, okay, the right hand side here, this is your program, your instruction, while the left hand side, this is your program memory. Okay, in which where your program, okay, your instruction here is being stored to your flash memory or program memory. Okay, so this is the address in which it started at address 300. Okay, so let's look at the first line. Load I R60 high remain out SPH R60. Okay, for the first line, okay, the first instruction here, what happened here is, okay, R16, what happened? High remain. So this is your remain 085F, in which 085F is a what we call 16 byte, all right, 16 bit, 2 byte. Okay, since it's a 16 bit or 2 byte, you can divide it into two portion or two segment, which is low byte and high byte. Okay, so 085F. Okay, from this 085F, which, okay, you already divided to two part here. Okay, so now, so this one here, we go to low byte, and this is for high byte, right? The 08 is for high and low is 05. Okay, you see here, okay, in this question here, in this instruction here, high remain go to R16. So you take the 08, put to your R16. Okay, so this is the content, 08 put to R16 for instruction number 1 lah. Okay, the first line of instruction, and then out SPH R16. What happened? Okay, so SPH out SPH R16. So SPH will get what value? Value from R16, which is 08. Alright, so since this is your stack pointer, okay, we see here this is your stack pointer, this is your program counter. All right, so at the beginning of your program memory, or at the beginning of your, what they call, when you started your micro-P, what happened is your stack pointer will point to this location here. Okay, this is your stack pointer. Why this location? Because your data memory is a volatile memory. Every time you boot up your micro-P, what happens is all the value inside of this data memory will be erased or become zero. So that's why here the stack pointer, the first value you get for SPH and SPL is 0, 0. But due to this second instruction here, out SPH R16 YPA 08, the value from R16 you put to your SPH. Alright, so now this one here becomes 0800. Your stack pointer now point to what as 0800. So now this one here will go to 0800, which is somewhere around here lah. Right, point to here. Okay, but you remember back, in order to use a stack pointer, you need to initialize your stack pointer at the uppermost of your memory location, which is the last memory of your RAM. Okay, so this is somewhere around here, which is at the middle of your RAM. Okay, now you're going to point this stack pointer so that it pointed to 0850. How to do that? Okay, and then load I R16 low remain. Alright, so R16 low remain, low value of remain is 5F. You put to R16, and then after that, okay, and then out SPL R16 and put R16 value to your SPL. So SPL equal to 5F. Okay, now your SPL now change from 00 to 5F. Okay, now what happen is your stack pointer you already initialized to your remain. Okay, so this is your stack pointer. Okay, point to this address 085F according this instruction number 4. All right, this instruction here, out SPL R16. All right, and then next instruction, load I R26 R35. So R26 you load with what value? 35, followed by load I R27 89. Okay, so R27 equal to 89, and followed by load I R28 48. Load I R28 48. Okay, so next, push R26. Okay, what is the push doing? Okay, the push, now you're going to push value from R26 put to your stack. Okay, what is the value of R26? R26 is 35. Okay, so you put value here. Okay, R26, all right, to your stack. Okay, so here you get 35, you put to your stack, which is value R36. What happened to your stack pointer? Your stack pointer will be decremented by 1. Okay, so now your stack pointer point to what address? 085D. Okay, so here at address 085F, what value you store here? You put here is 35. Alright, next, push R27. So R27, where is the value of R27? 89, you push to your stack. Now, what happens is, okay, you put 89 to your stack, and what happens to your stack pointer? This stack pointer here will be decremented by 1. Okay, now your stop pointer point to 5D. Okay, later we will see the program counter because I don't want to do the program counter because the program counter will keep updating for each of this line here. Alright, so now what happen is dekat alamat 085E, now you have 89. Okay, and then push R28. Okay, you take R28 value, put to your stack. What is the value of R28? It's 48. You put to your stack. What happened to your stack pointer? This stack pointer will be decremented by 1. Okay, so your stack pointer, your SP now point to what address? 08 immersive. Okay, so this is what happened. Okay, at address 085D. Okay, you push value, you save value to your stack. What is the value? Is 48. The value you get from R28. Okay, next, call modify. Okay, this instruction here, call modify. What happened for this call modify here? What happened every time you execute call instruction? Okay, so what happened here is before you go to subroutine modify. Okay, so this is the subroutine of your modify. Before you jump to here or go to this modifier, what happens is the microP will store the next address of your next instruction, which is this address here, 030C, to where? To your stack. Okay, so 030C will be stored to your stack. Okay, so in this case here, okay, you see 030C is 16-bit. Okay, 030C is 0C is this. Okay, this guy here is 60-bit, so you can divide it to low byte and high byte, make it a 8-bit data. Okay, so we recall back. Okay, for this one here, okay, you see where is my call instruction. Okay, this is the call instruction. Okay, so every time you subroutine is called, you save the address of the instruction just below the call instruction on the stack. Okay, so how to save your what we call address? Okay, to save the address, what happen is, where is my subroutine? Okay, this call instruction. Okay, this subroutine. Okay, so what happens is the lower byte. Okay, you see here how we're going to save the address to your stack. The lower byte is pushed onto the stack first. This line. Okay, you save the lower byte, which is 30, in this case here 0C, to your stack, followed by your higher byte. So in this case here, you save 0C and then followed by 0 3 to your stack. What happened to your stack pointer? Now your stack pointer will decremented by 2 because this is a 60-bit data, so it's incremented by 2. Now it point to at what address? 5A. Okay, this is what happened to this instruction here, call modify. Okay, before you go to the modify subroutine, what happen is you need to save, all right, the next address, which is of the next instruction, which is 030C, to your stack. Okay, in which we'll store the low byte first, followed by high byte. Okay, then after that you go to your modify. Okay, after you store the address here, all right, then you go to your modify SKEE 085DR27. Okay, see, you see here, this ORD 400. So that's why here the address, the program memory address here is started at 0400. Okay, because you origin your program memory location at this address. Okay, so the first instruction here is SKS 085DR27. Okay, what happened for the instruction? Okay, you want to store value R27 to address 085D. Okay, what is the value of R27? This is the value of R27, which is 89. The current value of R27. And now you're going to store to where? To address 085D. Okay, so you store here. Okay, so 085D. Okay, now we're going to have a new value. Okay, here instead of 48, now you store 89. And then SDS 085E with R28 means that you are going to store value from R28 to your address 085E. What is the value of R28? Okay, so the value of R28 is 48. The current value is 48. And then you're going to store to where? To your address 085E. So this is the address 085E. You store 40. Alright, next, ADD R28 R27. Okay, so now you're going to add R28 and R27 and put the result to your R28. Okay, what is your R28? 48 plus R27, 89, and put the result to your R28. So now your R28, we have the new value. What is the value of R28? Okay, so R28. Okay, the new value of R28 is equal to, you press the calculator and you get D1. Okay, this is your R28. Okay, so this is your R27 and this is your R26. Okay, so we put the current value lah. R27 no change, 89, and R26 is 35. Alright, and then after that RET. What happened when RET? Okay, every time you see the RET, what happened is the stack pointer, okay, will be decremented. Okay, what happened every time you see the RET? Okay, every time you see the RET, what happened is, okay, the value, okay, the address from the stack will be put to your program counter, and then your stack pointer will be incremented. Okay, you see here back. Okay, where is our RET? Okay, when the execution of the function is finished, the RET instruction at the end of the subroutine is executed. The address of the instruction below the call is loaded to the PC, and the instruction below the call is executed. Alright, so in this case here, okay, RET, what happened is this value 030C will be stored to your program counter. So program counter now will get what value? 03, okay, 03, 0C. And what about your stack pointer? Okay, the stack pointer now will be decremented by 2. Okay, it will point to here. Okay, 08. Okay, what about the value inside here? Is it 0 or it remains? It will remain. Okay, 030C will be remain, but the stack pointer will decremented. Will be incremented by 2. Okay, next, do we need to do the pop instruction? No need. Why no need? Because you see here. Okay, this question here asks you, okay, to find the content right after the instruction RET is executed. Okay, after the RET is executed, then you stop. Okay, so that one is your answer. No need to do this pop, 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 and jump. You just stop right away because you already execute the RET instruction. Why? Because according to this question lah. Okay, so you need to stop right away here. RET. Okay, so let's look at our what we call jawapan here. Okay, so you see here R26 35, which is correct. What about R27 89? R28 D1 also correct. Program counter, so this is your program counter 030C. See 030C. And then what about SPH as your stack pointer 085C, also correct. Alright, at address 085F you get 35 followed by 48, 89, 0C and 03. Okay, so just ignore the 00 and 00. So this is your answer for this question. Okay, let's look at another exercise here. Alright, so based on the program sequence, okay, given a program sequence, something like this, find out the result of affected register or memory address. Okay, you need to find out what, for each of these instructions, what are the affected registers or memory address. Alright, if not, you just leave it blank. Okay, and then assume the program has properly initialized the stack pointer to address 085F. Okay, it already says that this program here already initialized your stack pointer so that your stack pointer pointed to this 085F, which is your remit, and then the instructions are executed sequentially. Alright, so given a program instruction here, which is a table, okay, which is consists of your register, your stack and contents, okay, stack contents. So you need to find out what happened here inside of your register and your stack here. Okay, for each of these line. Okay, so this is the first line. This is your initial value. Okay, given that the initial value of R16 is 0, R17 also 0, 18 also 0, 19, 20 also 0. Stack pointer already initialized dekat mana? Alamat 085F, which is the stack content at address 085F is 0, 0. Okay, so this is your we are going to show how to do this what we call to answer this question here. All right, and then one more. Okay, I need to initialize this one. Okay, so I need to copy this one here. Yeah. Okay, so this is your stack pointer. Okay, so currently your stack pointer point to this address. Okay, you already initialize your stack pointer dekat alamat 085F. See, 085F, this is your stack pointer. Okay, so at address 085F is the stack content. Sekarang ni at 085F the stack content is 00. Okay, let's look at the first instruction. Load I R16 5. What happened here? You put 5 to your R16. So you just put 0, 5 kat situ. Okay, you just put 0, 5. Okay, I just change this one here, the format cell. Okay, to general. Is it okay with the general? Text, okay, with text. So 0, 5. Okay, so let's do is all the value inside here are in hexadecimal. Okay, so 5, this is a decimal, you put to R16, so you save 5, convert to hexadecimal, you also get 5, put to your R16. What about the others? Just leave blank because the others not affected. Alright, and then push R16. What is push R16? Means that you want to push this value here from R16 to where? To your stack. Okay, so push R16. So now you're going to push 05 to your stack. What happened to your stack pointer? This stack pointer will be decremented by 1 and okay, after you push, okay, so this become 0, 5. Okay, push R60. Okay, so step pointer sekarang ni point to what address? Okay, so this one here. Zero eight five E. Okay, currently is pointed to 085E, and at address 085F you have what value? 05. Right. So this is what happen when you do this push instruction. Push R16. Do your R16 change? No change. Okay. And then decrement R16. What happen when do you decrement R16? R16. Okay. What happened to R16? R16 will decremented by 1. So now you become 4. Branch not equal. What is branch not equal? Okay. If R16 not equal to 0, what happen is you branch to simpan. You go here. You go to simpan. Okay, because since currently your R16 is 04, and then you go to simpan, and then push R16. You push back your R16. What is your R16? R16, the current value R16 is 04. Okay, you push to your stack. What happened to your stack pointer? Stack pointer decremented by 1. So now what happening? So this one here now, okay, so it's pointed to 085D. And what happened here? Dekat sini, okay, we just take the current value lah. Okay, so what is the current value? So this one here actually, okay, so 085E, okay, at address 085E you have 0, 4. Okay, next, decrement R16. So what happened? R16 now become 0, 3. Okay, so previously 0, 4, you R16 become 0, 3. Branch not equal. Okay, still not equal to 0. What happens is you go again to your simpan, push R16. So push again your R16. So R16 0, 3, you push to your stack, and what happens to your stack pointer will be decremented by 1. Okay, now this one here point to what? 8C, and this we take the current value. Okay, the latest value, so this 8D, and D is berapa? So 3. Okay, let's see. This is the current value 085D. You have 0, 3, and then decrement R60 again. So this one becomes 0, 2. Branch not equal. Yes, not equal because you have, or you still have a value here. So not equal to 0. So you go to simpan, push R16, masukkan again your R16 to your stack, 0, 2 here. And what happened to your stack pointer? Stack pointer will be decremented by 1. Okay, so now your stack pointer point to what address? 085B. Alright, so what is the stack content? So at address 085C you have 0 to 085. C you have 0. Okay. Decrement again R16. So R16 now from 2 decremented by 1, you have get 1. Yes, you still have value here. Okay, branch not equal. Yes, not equal to 0. So you branch again to your simpan and push R16 one more. So this one here becomes 0, 1, and step pointer will be decremented by 1. Okay, now what happen is step pointer point to what alamat? 085A. Okay, the current value of stack pointer 085A. What about your stack content? Okay, we take the current value is yang paling tinggi lah. The top one is 085B, 085. What is the value? Is 0, 1. Okay, and then decrement R16. What happened? You decrement again your R16, so now your R16 becomes 0. Okay, when R16 is equal to 0, do you need to go to simpan? No, because now the R16 0, so you go to pop. Okay, So pop R17. So what happens when you pop? Okay, when you pop here, what happens is you take the value from your stack, put to your register. Okay, so this one here, you pop. Okay, you pop what value? 01. Okay, put to your R70. So R70 we have 01. What about your step pointer? Your step pointer will be incremented by 1. Okay, so step pointer here now point to what address? So you can point to 085 B. Okay, next pop R19. Okay, so you pop again your value from stack. What is the value from your stack that you're going to pop? 02. Why? Because step pointer now point to this address, correct? Okay, so you pop this value here, put to R19. Alright, so this one here 02, put your to your R19. What happened to your step pointer? So this step pointer now will be incremented by 1. So now it point to what address? The new address is 08 5 C. Okay, and then pop again, pop R18. Okay, so what is the value that you're going to pop? 03. You pop to R18. Okay, so 03 go to R18. What happened to your step pointer? Step pointer will be incremented by 1. Okay, so it will be incremented by 1. So this now your step pointer point to what address? 085. And then pop again, pop R20. So now you're going to pop this value here, 04, put to your R20. So this one you got 04. And what about your step pointer? Step pointer again will be incremented by 1. And now your step pointer point to what address? 085. So this is the answer for this question. So let's check whether our solution is correct or not. Right, the first line, okay, you see 05. Okay, so this one was correct. What about this one? Okay, push R16. Okay, 085A, 085B is 01. Also correct. You see here. Right, and then decrement R16. R16 now become 0. Correct. Okay, so this one is 01. 085B. And this is R90 is 02. 085C. And then R18 now become 03. Okay, step pointer point to address 085D. And R20 have 04 and this is 085